Hello, thank you, Kristen. I'll try to share my screen now from over here. Okay, I hope you can see that. Yes, I think the technicalities around implementations of linked data can be quite complex, but the basic principles are simple, and we thought it was worth highlighting these now as we have new members and people in the audience that have little familiarity with them. So I'll start with a problem. A problem I hear often when I discuss with colleagues about documentation is that we've got a documentation database or a system in our organization, but it doesn't really talk to the main catalog of the organization. So we have two systems, but they don't talk to each other. We cannot search across each other. An example is the Bodleian library. They have a good system to organize their conservation photographs and their related metadata. But that system doesn't really talk to the new manuscript catalog, for example. So if somebody is interested to retrieve manuscripts based on content, on the content of the manuscript from the catalog, they wouldn't be able to combine that with conservation information on whether the item can be handled or it can be digitized. With linked data, of course, this is possible. And Nicole Gilroy and I demonstrated various examples of that last year in the Oxford project. Another example is from the National Museum of Wales and the work that Christian Baars has been doing. It's a good example of trying to correlate the condition of specimens from a collection, in this case, the mineral collection of the museum, with measurements from the environment. So the temperature and humidity measurements that we get come from a different system. At the moment, if I wanted to check whether the condition of my collection of specific specimens is reasonable, given the environment I've got, I would have to do it manually. But again, the point is that with linked data, these two data sets can be combined and queried as a single entity. Even the process can perhaps be even automated. So making systems talk to each other inside organizations is one problem. A similar problem is collecting data from different organizations. For example, say I'm interested in early bookbinding structures and I want to gather together observations by conservators from different libraries. What I would typically end up with is different data sets, say different spreadsheets with data from each organization. So this is what I've got. And what I would do is I would create my own spreadsheet with the intention, of course, to bring all of these records together. There's a bit of an exercise here. I need to match each column in the spreadsheets with a column in my own spreadsheet. I have to do it again and again, and it takes me a while, but eventually I get all my data in one spreadsheet. And then, of course, I'm able to sort and query in there, which is a lot easier. And linked data helps very much with this process. But let's look at it in a little bit more detail. Usually, one of the columns that I get from these spreadsheets contains a number, some sort of identifier to tell me which manuscript I'm talking about. If I bring all these things together in my spreadsheet, I can see the numbers there, and this is perfectly fine. The problems start, of course, when two different libraries have used the same sequence of numbers to give identity to their books. When I take these numbers into my spreadsheet, it appears as if I've got the same book twice with different observations about the book, yeah? Which is, of course, a big problem. So to solve that, linked data says, okay, let's make sure that the identifiers we give to our books are guaranteed to be unique. So unique at a global level, yeah? And a good system to guarantee this uniqueness is to use web addresses. A web address corresponds to one web page. Yeah? Nothing else comes up when I type in that web address. So I can make that web address correspond to a book if I want. And therefore, when these things go into a summary spreadsheet, we do not confuse the two items. Yeah, we can always separate them. Right, for those who are interested in acronyms, these things are called URIs, but it doesn't matter. Right, so I've got this web address over there, and that points to a book. And I've got a conservator who can make various statements about this item. There's no software, of course, that will understand what a book is. Therefore, the conservator needs to specifically explicitly declare, as it were, that this item is a book. And then the conservator can say other things, that it's made of parchment, or that it has a strap attached to it, and so on. And then we have another conservator who perhaps is more interested in fastenings for books and straps, and they can make extra statements about the strap, that it's of a specific type, in this case a triple braided strap, or that it is made of leather. Now, the word strap on its own doesn't tell us that we're talking about the same thing. We could be talking about different straps. If we want to make sure that we're all referring to the same strap on the specific book, following the same principle, we can assign an address to it, a universal identifier. So these two are the same, and I can now merge the two sets of observations into one. This means that the first conservator is now able to take advantage of the observations of the second conservator. And it's a good idea, of course, to replace the rest of the terms over there. So are we sure that everyone means the same thing when we say triple braided strap? Perhaps not. One way of making sure that we're all talking about the same idea is to replace these words with new web addresses. And these web addresses come from a thesaurus. A thesaurus would provide these identifiers. And thesauri are so important in the linked data world that, and that's the reason why we have dedicated the first workshop in Stanford in June to talk about thesauri in conservation. Now, the only part that's left without identifiers is the middle column, which is the column that connects the other two. And of course, you will not be surprised that we can replace all these things with identifiers as well. And these come from what we call the CDOC-CRM ontology, which is basically a collection of different relationships connecting either side of that table. So, for example, a relationship between the book and its component, or between the strap and its material, and so on. Again, these relationships are really important for linked data. We're focusing on these on the second workshop in September in London. And we'll have the chance to talk about this again in the project. Right, another thing is that I don't really like to type too much. So I can replace the beginning of each of these web addresses with a shortcut. You can see what has happened here. This shortcut replaces all of this. And this is exactly the same thing. It just makes my life easier. It makes these addresses a bit shorter. So don't worry about it. You will notice, of course, that all of these statements share a common triple structure, which is why you often hear about triples and triple stores when people are talking about linked data. Again, for those who care about acronyms, this structure is called RDF, but it is the sort of the generic, the common structure that everybody follows to provide all these statements. Again, we will have a chance to talk about that. So to make systems compatible, we have three things. We have global addressing, making sure we all point at the right thing. Global context, making sure that we'll talk about the same thing, that the context is the same through thesauri and ontologies. And finally, the triple structure. And with these three components, we should be able to solve the puzzle of making data sets in conservation talk to each other. I believe that conservation is in a unique position to benefit from linked data. We produce really rich data, and there's great potential there, and the field is relatively small if compared with other fields, which means that any efforts for wider coordination and integration are more likely to succeed. Right, so this was the 10-minute introduction crash course to linked data. As I said, we will have the opportunity to discuss these things again during the project. I will now hand over to Jay Hoffman from Gallery Systems to hear their views on why linked data could prove useful. Jay, are you able to take over the screen?